Hello, in this video we are going to work on Algebra 1, Lesson 1, and there's two parts to this lesson. There's the addition and subtraction of fractions, and then there's lines and segments. So in 1a, the first topic, adding and subtracting fractions, they give you two of these fractions, 5/11 plus 2/11, and you're going to add them, and then they take 5/11 minus 2/11 and you subtract them. So let's take the addition first. You may remember if you had Saxon 8-7 last year, or maybe another math class last year where you were adding fractions, that you add the numerators, so 5 plus 2, which is 7, and then you keep the same denominator, so the answer is 7/11. And then let's look at what that would look like for subtracting. Same thing, we're going to subtract the numerators, 5 minus 2, which is 3, and keep the same denominator, 3/11. Now, if you may have been taught how to do this and you remember how to do it, and maybe you don't understand why. So I added a little extra in the lesson here to talk about why that is. All right, let's talk about some fractions that are easier to picture. It's hard to draw 11ths, right? So I thought, well, we'll make it a little easier. We'll think about fourths. So let's think about fourths. I'm going to draw a circle, and I'm going to cut it up into 4 pieces. Now imagine all of those pieces are equal, okay? So I'm going to draw this here, and we're just going to color in 1/4. That blue where I colored in is 1/4, and this blue that I colored in here is 1/4. So if you add a fourth and a fourth, you end up with 2/4. The size of the pieces doesn't change at all. This is a fourth, and this is a fourth, and you have 2 of them, so you have 2/4. Now, sometimes what people will think, and I'm going to write it up here in red, this is not right. Okay, so we're going to put no, this is not right. Okay, if we add 1/4 plus 1/4, they'll think, well, we add the tops and then we add the bottoms, which is 2/8, and then I'm going to simplify both of them and I get 1/4. Oh, wait, hold on. How's that possible? I added something to it again and I get the same answer? That doesn't make sense. That can't be right. So that gives us a problem here. We know that that can't be right. So you can see what I did down here in blue. That is why we add the numerators, but we don't add the denominators. The denominators are telling us the size of the piece, okay? The numerators is how many pieces we have. So that's why we add the 1 and the 1, and we keep the same size piece, okay, which is a fourth. Now, we can go down here and simplify it, and we get 1/2. So a fourth plus a fourth would equal a half. And if you take this fourth here and you move it over there, you can see that those 2 pieces equal 1/2 of the circle. So it makes sense. Okay, so that's the why. Let's go ahead and do it with subtraction. 1/4 minus 1/4, using the same rule. 1 minus 1 is 0 over 4, and that's just equals 0. The size of the pieces are fourths, and if you take a fourth minus another fourth, you end up with nothing, right? And we could draw that. Here we go. We've got a fourth. And now we're going to take away that fourth, okay? So I'm going to pull out my red here, and I'm going to take away that fourth, so it's gone. Well, that leaves me with nothing, okay? Now, if you tried to do it another way, this is going to be the wrong way. No, don't do it this way. If you do 1/4 minus 1/4 and you say 1 minus 1 is 0 over 4 minus 4 is 0, then you end up with the 0 divided by 0 thing, which is actually not equal to 0, okay? And you'll learn that later in this course. So that's kind of tricky. But you can see here where we did it in blue that it works. Okay, and we get a reasonable answer. So hopefully that will help you to understand the why. And if you don't quite get the why just yet, but you know how to do it, that's okay too. Okay. All right, let's move on to A. We need a common denominator between 3 and 5. One way you can think of it, and you don't have to write this, but I think it's useful for me to show it so you can see what's going on in my head, is I'm looking at common multiples of 3 and 5, and I think about 5, 10, 15. Oh, hold on. 15. I know that that's a multiple of 3. 3, 6, 9, 12, 15. They have that in common. So I can make both of those become 15. I'm changing the size of the pieces, but I need the value to be the same. Just like 2/4 is a half, 1/3 is the same as how many 15ths? Well, what do I need to do to the 3 to make it become a 15? I'd multiply it by 5. And what would I do to the 5 to make it become this 15? I would multiply by 3, and I get a 6. So now when I add those together, 5 15ths plus 6 15ths is 11 15ths. And that won't simplify. So I can just circle that and save that as my answer. All right, I'll move on to B. I'm going to think about the numbers 3 and 8. And you can probably think of this in your head. I usually start with the bigger number, 8, 16, 24. We know that. 3, 6, 9, 12, 15, 18, 21, 24. Those are in common. So I can make them both become 24. What do I need to do to the 3 to make it become a 24? I multiply it by 8. And what do I need to do to the 8 to make it a 24? I multiply it by 3. And now I have them with common denominators, the same size pieces, so I can go ahead and subtract those. 16 24ths minus 3 24ths would give me 13 24ths. And that is the answer for this problem. For C, I've got a 5 and an 8. And maybe you don't have to list this out this time. I can think about multiples of 8. And multiples, if I know my divisibility rules, multiples of 5 have to end in a 0 or a 5, right? So I want a multiple of 8 that ends in a 0 or a 5. Well, I can think of 40. So I can multiply that by 5 to get the 40. So I can multiply this by 5. Okay. And then here I can multiply by 8 to get the 40. Now, what do I do with the whole numbers? Because these are mixed numbers. Well, those just stay with it. And I can add those two together. This 13 plus this 2. We can do that. We can say that's just 15. And now I can add those fractions together. 24 40ths plus 5 40ths would be 29 40ths. And that won't simplify. So it's 15 and 29 40ths. Let's look at D. D is 13 and 3/5 minus 2 and 1/8. So again, I'm looking at the same problem again, but I'm going to subtract them. Well, I already know that I'm going to have 40, right, on the bottom. And I had to multiply this by 5. I have to multiply this by 8. And I keep my whole numbers. Now I'm just going to subtract them. 13, it's my whole number, minus 2 is 11. Now I'm going to take my fraction, 24 up here, minus this 5 is 19. And that is my final answer because it won't simplify. And then E. Again, we have something very similar. We can use that 40ths again. That's helpful. Times 8, times 8, times 5, times 5. So here, 3 times 8 is 24. That's 13 and 24 40ths minus 2 and 7 times 5 is 35 40ths. And then I run into a little bit of a problem here because what I've got is this fraction is smaller than this fraction. So I can't do 24 minus 35. Now, it's tempting to do 13 minus 2 and then do 35 minus 24, but we can't do that, okay? So what we're going to do is we're going to borrow so that we have enough in the numerator of this fraction to be able to subtract. So let's see what that looks like. I've got 13 wholes right here. Let's take away one of those wholes and I would have 12 left, okay? When I take that one whole, it's not just equal to 1, okay? 1 is the same as 2 over 2 or 3 over 3 or 4. Whoops, that's not 3. 4 over 4. I can write a 1 any way I want. 1 has lots of nicknames. I could put 10 over 10. I could put 20 over 20. I could put 30 over 30. I could put 40 over 40. Look at that. That would make it match the fraction that I have already here. So I think if I think of the one that I just borrowed as 40 over 40, okay, so let's rewrite that. Now I have 12 wholes, but I just took this whole away that would have made it the 13 original, and then I still have this 24 40ths. I can put these two together, 12 and 64 40ths. Now, why did I do that? Well, so that I can now subtract these two fractions, okay? So the key here to understanding this is that when you borrow and you get the 1, this 1 that went away here, it went from 13 down to 12, you can call that 1 whatever you want to call that 1. You pick it. Make it easy on yourself. Okay, we want a common denominator, so we picked 40, right? So what I'm going to do now is I'm going to go ahead and subtract. So I can do, I have enough here now to be able to subtract this from it. So let's take the whole numbers first. 12 minus 2 is equal to 10. 64 minus 35 is 29. And then we have a 40th because we keep that denominator value the same. So I'm going to take that as my answer. 1B reintroduces or reminds you of lines and segments. And I think I'm going to go ahead and stop the video and finish this in the next video.